Hey guys, it's me again. Hopefully you completed last week's lesson and quiz on comets. If not, make sure you go back and do that. All of the quizzes are still there in Google Classroom, so you can go back through, find them, take them. There's no late penalty, just make sure you get them done so you don't have anything to worry about once we finish up this learning at home stuff. Next week should be the last week of actual lessons, and then we'll have a week to catch anyone up who needs to be caught up, and then that'll be it for the school year. So try to make sure you're getting all this stuff done. It's much easier to change any grades that need to be changed during the school year. Don't wait till summer and then email and try to figure out how to get things fixed. It's much harder then. This week we're going to do galaxies. So we're going to go ahead and jump right in and talk about those. All right. So galaxies. Here you can see I have a lovely picture of the Milky Way galaxy here. What do you all think of that? Hopefully, your first reaction to that was to call BS because we don't have a picture of the Milky Way galaxy like this. And hopefully you're thinking, well, that wouldn't make any sense at all to have a picture of the Milky Way because you would have to get really, really, really far away from the Earth to take a picture of the Milky Way galaxy. The Milky Way is some 100,000 light years across. You'd have to go at least that. So the Earth is about 27,000 light years from the center. You'd have to go thousands and thousands of light years away just to get far enough away to take the picture. And then you'd have to send it back to the Earth. And when you send things, they travel at the speed of light. So you'd have to wait thousands and thousands of years on top of that to get the picture back. So we are nowhere close to having a picture of the Milky Way, anything like this. So anytime you ever see a picture of the Milky Way out there, it's either another galaxy or just an artist's interpretation of the Milky Way. So there are no real pictures of the Milky Way. But we have been taking pictures and sorting galaxies for a very long time. The first person to begin doing it was Charles Messier. He cataloged 103 objects. And what he was doing was he was looking for comets. And basically, he just started cataloging objects, and he was just saying, these things are not comets. Well, most of these things, they were actually star clusters, nebula, or galaxies. And his catalog is still used today to refer to some objects. So you might hear someone call something a Messier object, or by the classification like M82, things like that. Right now, we have 110 Messier objects. Here are the Messier objects. So here are the current pictures we have of the different things that Charles Messier cataloged. As you can see, there are quite a few galaxies in this selection here. Looks like 31, 33, 51, 66, 81, and these are just the spirals that I'm picking out for you. There are different types of galaxies that we'll be talking about. Quite a few of these are galaxies. He didn't know it at the time, but they're galaxies. Today, though, we sort galaxies into 4 general categories, and they were created by Edwin Hubble. So we have spiral, barred spiral, elliptical, and irregular. This diagram right here, it's cool looking, but the way it's drawn, it implies that a galaxy starts off elliptical and then becomes spiral. That is not like a general evolution of a galaxy. They don't start elliptical and become something else. So please don't assume that that's how this works. It's just like this, I think, because people thought it looked cool like that. Now, going through each of the types. So spiral is probably the one you're most familiar with. These have a galactic bulge in the center. So it looks kind of like a lump or a ball in the center of the galaxy. And they have the typical spiral arms, like the whirlpool type look. This is almost certainly the type of galaxy you think of when you are thinking of a galaxy. Then we have a barred spiral. The spiral arms are still there, but that center area kind of becomes like stretched out and elongated. It's called a bar, so hence the name barred spiral. Elliptical galaxies, so these are very symmetrical. There's no spiral arms, and they are either very round or they can be very oval. And irregular is just kind of whatever. There is no defined shape. No defined size. There's no obvious shape or order or anything to it. You won't see spirals in them. It's just kind of a mess. So these are your 4 basic types. I do have a little bit more to say about a couple of these types, though. So with spiral and barred spiral galaxies, you can further classify them based on the tightness of their arms. So the more tightly wound the arms are, the more we would say it is an SA type. So if the arms are very tightly wound, very nice tight spiral, it's an SA type spiral galaxy. If the arms are a little more spread out, you'd call it an SB. If the arms are really spread out, call it an SC. So these further classifications just allow you to tell someone, hey, this galaxy is a really nice tight spiral, or it's kind of a more spread out loose spiral. And this applies to both spiral and barred spiral galaxies. Elliptical galaxies, I already mentioned, can be really round or really oval, so we can give them further classifications as well. If they're basically a perfect circle, perfect sphere, call it E0. So E0 tells you that it's really round. The number gets higher as it becomes more oval, more stretched out. So we go from E0, round sphere galaxy, all the way up to E7, where it's kind of like stretched out, oval shape. Now, these galaxies, they can have populations of stars in them. So we have 2 major populations of stars found in our galaxies. Population 1, population 2. Those names refer to the metal content of the stars. Now, in astronomy, anything above helium is considered a metal. Now, I know on Earth and in chemistry, you wouldn't do that. But in astronomy, anything above helium is considered metal. So when we say something is metal rich, we're saying that it's got stuff that is heavier than helium. Metal poor means it has very little of that stuff heavier than helium. So population 1 are the metal rich stars. And these tend to be younger stars. The main reason for that is early stars in the galaxies and the universes, or the universe, were producing the elements inside of themselves, and then they explode, and all these heavier elements are released. And then stars like our sun come along, and as they form, they take in these heavy elements. And so younger stars have these heavy elements that have been produced for long periods of time. So our star has these heavy elements that it would never actually make, but it's got them because it took them from other dead stars. So younger stars tend to be more metal rich than younger stars, or sorry, than older stars. So population 1 is your metal rich young stars. Population 2, metal poor old stars. And where you find them in different places. The old stars and the young stars are usually found in different parts of your galaxy. So the young stars, the population 1, are found in open clusters, which we'll talk more about on the next slide, and the arms of spiral galaxies. Population 2, the metal poor stars, the old ones, are found in globular clusters, which are on the next slide, and they can be found in the halos of spiral galaxies. So they're found on the outskirts, kind of like the upper and lower parts of the galaxies, as well as elliptical ones. So the arms, the really bluish looking arms of these galaxies are filled with young stars. Now those clusters that I was telling you about, open clusters, like I said, are where you find young stars. These are in spiral arms. The globular clusters, this is where the old stars are, and they're found near the centers of galaxies and kind of up and down, like above the galaxy, above and below it. And I have a couple images to show you. So the open clusters tend to have less stars than the globular clusters. So here is the disk of our galaxy. These are the arms. In the arms are where you'll find your open clusters, your population 1, your young stars. So our sun is a population 1, fairly young star. You would find it in the arms of our galaxy. The halos, you can see, they kind of go up and below the galaxy. This area is where you're going to find the older stars. So your globular clusters, your metal poor, your population 2 stars. They don't hang out in the arms so much. They hang out in the halos and near the center. So have you ever noticed that when you look at pictures of galaxies, the center tends to be like really yellow or white? You're seeing older stars. So here you see more of the halo. They kind of hang out on the outskirts, on the above and below the disk. And then inside the disk is where you're going to get your open, young population 1 stars. And of course, at the center of most galaxies is a black hole. So this, you may remember sometime last year, the first image of a black hole was taken. So this right here is an image of a black hole. Now, mostly what you're seeing is the shadow and the gases that around the black hole that get superheated. But it is the best image we have taken of a black hole directly. So most galaxies have a supermassive black hole at their center. They can be millions to billions of times the mass of our sun. And they have, of course, tons and tons and tons of gravity associated with them. Their gravity, though, isn't actually strong enough to hold the entire galaxy together. We briefly hinted at this before. This is where I would talk more about dark matter, but we just don't have the time. Dark matter is actually the thing holding our galaxies together for the most part. It kind of like lines the outer edges of them and it helps hold a galaxy together, because the black hole and all the stars just isn't enough. So there's got to be something else out there, and we believe it's dark matter. All right. So that is where I'm going to stop today for like an overview of galaxies in general. Next week, we'll talk about the Milky Way specifically and our location in our little cluster of the universe. So make sure that you go through this video lesson. Try to get this quiz done by Friday. If you're behind, try to catch up. You don't want to get yourself more behind and have to finish all the quizzes the last week of school. I will do another post probably next week, since that'll be the last quiz, with all links to all the quizzes again. So if you do need to catch up, they'll all be right there. If you have a question, just email me, make a post in Classroom, whatever you need. I'll be available on Thursday for office hours as well. So anything you need, just let me know. Be sure to like and subscribe, and I'll see you guys in the next one.